I'm going to talk about the secant, cosecant, and cotangent functions. All right? The secant function is often abbreviated with the letters S, E, and C. So the expression I just wrote down corresponds to the secant of an angle measure theta. The cosecant function is often abbreviated with the letters C, S, and C. So what I just wrote down corresponds to the cosecant of the angle measure theta. The cotangent function is often abbreviated with the letters C, O, and T. So the last expression corresponds to the cotangent of an angle measure theta. All right. Now you may know that the cosine, sine, and tangent functions are defined with respect to the coordinates of points on a circle centered at the origin of an xy coordinate plane. Let me draw a diagram of what I'm talking about, and then we'll continue. All right, so in the picture, I have a circle with a radius r centered at the origin. And I've defined I've denoted a point on the blue circle with a radius r with a purple dot, okay? And I've named the coordinates of that point x and y, okay? I've also drawn a right triangle with the hypotenuse being the radius, corresponding radius for that point on the circle. And I've labeled the lengths of the legs of that right triangle. Okay? So for such a point and for such a circle and right triangle, then the sine, cosine, and tangent values of the angle theta, let me show you the angle that I'm referring to when I talk about theta. So right there, the sine, cosine, and tangent values of the angle measure with respect to the left angle of that right triangle can be defined in terms of ratios with respect to x, y, and r. Right? So for example, the sine of theta is the ratio y to r, or y over r. The cosine of theta is x over r, and the tangent of theta is y over x. Now, the secant, cosecant, and cotangent functions are defined in terms of similar ratios. The secant of theta is equal to r over x. The cosecant of theta is equal to r over y, and the cotangent of theta is equal to x over y. Now notice that the secant of theta is equivalent to the reciprocal of the cosine of theta. Notice that the cosecant of theta is equivalent to the reciprocal of the sine of theta. And notice that the cotangent of theta is equivalent to the reciprocal of the tangent of theta. All right, those facts are going to be very useful when calculating values for the secant, cosecant, and cotangent functions. Okay? In fact, let's close this video by finding some values for the secant, cosecant, and cotangent functions with respect to special angles that don't require a calculator. So I'll do one and then I'll have you do some. So suppose I wanted to know the secant of pi over 3 radians. So I might start by focusing on the fact that that's equal to the reciprocal of the cosine of pi over 3 radians. Then I would maybe somehow figure out that the cosine of pi over 3 is a half. So that would lead me to the fact that the secant of pi over 3 radians is equal to 2. Okay? Now let me have you try some. Would you please try to find the cosecant of pi over 6 and the cotangent of 30 degrees. All right? So pause the video and try to evaluate those now. Okay, I'll go ahead and work them out also. So for the cosecant of pi over 6, I might start by realizing that that's equivalent to the reciprocal of the sine of pi over 6, which is equal to the reciprocal of 1/2, which is equal to 2. And the cotangent of 30 degrees, I might work that out by starting with the reciprocal of the tangent of 30 degrees, which is equal to the cosine of 30 degrees divided by the sine of 30 degrees. And that's equal to root 3 over 2, that whole fraction all over 1/2, which simplifies to the square root of 3. I hope that's what you got. Okay? Now let's close by having you try some slightly trickier ones. Can you find the secant of 5 pi over 6, the cosecant of 240 degrees, and the cotangent of minus 60 degrees? So give those a shot, all right? Pause the video and try those now if you want to. All right, so I'll go ahead and work these out. So for the secant of 5 pi over 6, let's start by expressing it as the reciprocal of the cosine of 5 pi over 6. Then let's realize that that's related to the cosine of pi over 6. The only difference is a minus sign. So that gets me that far. And then the cosine of pi over 6 is root 3 over 2. All right, so simplifying that, I have minus 2 over root 3, or minus 2 root 3 over 3. All right, so you see how I do it in steps, okay? And every step gives me a little bit easier expression to work with. The cosecant of 240 degrees, so that's the same as the reciprocal of the sine of 240 degrees. And let's see, so 240 degrees is, 240 is 180 plus 60. So I can see that 60-degree angle with respect to the third quadrant. So that's going to have, it's going to be, the sine of 240 degrees is minus the sine of 60 degrees. So that gets us to there. And then the sine of 60 degrees is 1/2. Excuse me, the sine of 60 degrees is square root of 3 over 2. So let me make that correction. square root of 3 over 2. All right, so then we have the same thing we had before, in other words, for the last exercise, so minus 2 root 3 over 3. All right, and then last one, so the cotangent of minus 60 is equivalent to the reciprocal of the tangent of minus 60, and that is, the tangent of minus 60 is minus the tangent of 60. And so that gets me to a form that I could now replace with sine and cosine. Of course, I could have replaced the original immediately with sine and cosine. That may have been a quicker way to get to this step. So then this is minus cosine of 60 over the sine of 60. And the cosine of 60 is 1/2. The cosine of 60 degrees is 1/2. The sine of 60 degrees is square root of 3 over 2. So I'll let you do the intermediate steps on paper, but that would give me minus 1 over root 3, or equivalently minus root 3 over 3. All right?